Hello, welcome to physics class. So today we shall be looking at measurements and units. Physical quantities in physics are often measured, given a value and assigned a unit. It is these units that are used to describe or explain physical quantities. Generally, physical quantities are quantities that can be observed, measured, and also given a value. Furthermore, physical quantities are subdivided into two, which are fundamental quantities and derived quantities. So today we shall be discussing fundamental quantities and units, derived quantities and units. Thereafter we move to SI units. So let us begin. Fundamental quantities. Fundamental quantities and units. Okay, fundamental quantities and units. There are some physical quantities that cannot be defined in terms of other quantities or can be derived in terms of other quantities. Such quantities are independent of other quantities, or rather, other quantities are dependent on such quantities. So we call such quantities fundamental quantities. Now the fundamental units are the units of these fundamental quantities. In other words, just as the fundamental quantities are quantities upon which other quantities depend, the fundamental units are also units upon which other units depend, or they are units that cannot be defined. So by definition, we say fundamental quantities. These are quantities that cannot be defined in terms of other quantities. Full stop. Fundamental units So we see the fundamental quantities are quantities that cannot be defined in terms of other quantities. Fundamental units are units that cannot be defined in terms of other units. They are the units of the fundamental quantities. So we have various fundamental quantities, but we shall restrict ourselves to 7 basic fundamental quantities, which is what is required of you to commit into your memory. So let's look at the fundamental quantities and their units. Quantity, units, unit abbreviation. So we have length, mass, time, temperature, which is thermodynamic temperature, electric current, amount of substance, luminous intensity. So for length, the unit is meter. Mass, the unit is kilogram. Time, the unit is second. Temperature, Kelvin. Electric current, ampere. Amount of substance, mole. Luminous intensity, candela. So unit abbreviation for length is m, kilogram, k, small letter, second, s, small letter, Kelvin, sorry, kilogram is kg, pardon, Kelvin, k, capital letter, ampere, a, mole, mole, candela, c, c, d. All right. So these are 7 basic fundamental quantities, their units, and the unit abbreviation. Okay, having said that, so just as we have the fundamental quantities and units, we also have the derived quantities and units. So let us look at the derived quantities and units. Derived quantities and units. Okay. Just as the name implies, derived quantities, they are derived from the fundamental quantities. So the derived quantities are quantities that are a combination of 2 or more fundamental quantities. So also the derived units are the combination of 2 or more fundamental units, and they are also the units of the derived quantity. So derived quantities Okay. Derived quantities and units are obtained from the combination of two or more fundamental quantities and units. So the derived units are the units of the derived quantities. So just as we have the fundamental quantities, unit and unit abbreviation, so we also have the derived quantity, their derivation, as well as the units. So let us look at some derived quantities, their derivation, as well as the units. So we have quantity, derivation, and units. So first we have area. The area formula of area is given by length times breadth. So you can see that the area is a combination of two fundamental quantity, length and breadth. Breadth is a form of length. So to obtain the units, we use the unit of length to multiply the unit of breadth. So the unit of length is meter. Unit of breadth is also meter. So meter times meter will give us meter square. Next is volume. The volume is length times breadth times height times height. So our unit becomes meter times meter times meter, which is equal to meter cube. Next is density. The density of a substance is the mass per unit volume of the substance. The unit of mass is kilogram. The unit of volume is meter cube. So if I take this meter cube up, the power of 3 becomes minus 3 according to the law of indices. So this is kilogram per meter cube. Or you write it this way, kilogram. If you have a slash here, you retain the positive power of m, which is m to the power 3. Next is velocity. Velocity is the rate of change of displacement. The displacement with respect to time. So our unit becomes, unit of displacement is meter, time is second. So velocity becomes meter. The power here is 1, so you take it up, it becomes minus 1. Or you can write it this way, slash. Okay, so we have area, volume, density, and velocity. So these are your derivations, and these are also their units. So let us consider other derived quantity, their derivation, as well as their units. Okay. Now before I proceed, take note that the unit of speed, the unit of velocity is same as speed. So the unit of velocity, which is the meter per second, is the same for the unit of speed, which is the meter per second. So let us proceed. Acceleration. Acceleration. Acceleration is defined as the rate of change of velocity with respect to time. So we have velocity over time. The unit of velocity is meter per second. The unit of time is second. So we have meter per second times, if this goes up, this becomes 1 minus 1. Now since this is S, this is S, so we add the power. So this gives me meter minus 1 gives minus 2. Or you write this as meter slash second square. Next is force. The force acting on the body is given by the product of mass and acceleration. So force is mass times acceleration. Pardon? The unit of mass is kilogram. The unit of acceleration is meters per second. So it's per second square rather. So multiply this gives us kilogram meter per second square, or kilogram meter slash second square. Next is pressure. The pressure acting on the body is the force per unit perpendicular area. So this gives us a unit of force, which is kilogram meters per second square over area meters square. So this is equal to kilogram meters per second square times meter square. So, 2 power minus 2. So this is equal to, since this and this are same, the power here is 1. 1 minus 2 is minus 1. So we have kilogram per meter per second square. But the SI unit of pressure is the Pascal. The Pascal is equal to, if we come here, the SI unit of force is Newton, that of area is meter square. So Newton over meter square is Newton per meter square. Of Newton per meter square. This is also equal to kilogram per meter per second square. Let's take note here, the SI unit of force is Newton. So the Newton here is also equal to kilogram meter per second square. Next is work. Work is the product of force and displacement. Force displacement. Pardon, let me take this down so that I don't have to. Work, force, displacement. Excuse me, beg your pardon. Alright. Now the unit of force is kilogram meter per second square times displacement is meter. So you multiply this gives you kilogram, meter here. So meter is meter, it gives you what? Meter square per second square, or write this as kilogram meter square per second square. Now again, the SI unit of work is joule. So the joule is also equal to, now if we come here, the SI unit of force is Newton, that of displacement